The Sun, Features and Activities, Part 2 of 2. Sun Activities and/or Features. Shown in diagram. Nanojets and Nanoflares. Plumes and Plumelets. Solar Flare. Solar Wind. Spicules. Sunquakes. Sunspots. Not shown in diagram. Heliosphere. Parker Spiral. Solar Energetic Particles. Supergranules. Heliosphere. The Sun's constantly outflowing material, the solar wind, inflates a bubble in space called the heliosphere. The heliosphere encloses all of the planets and is filled by the Sun's plasma and magnetic field. In interstellar space outside the heliosphere, the interstellar medium and the galactic magnetic field are dominant. The heliosphere acts as a shield for our solar system, blocking many of the high-energy galactic cosmic rays from elsewhere in our galaxy. Of the spacecraft sent from Earth, only the twin Voyager spacecraft, traveling since 1977, have been confirmed to have made it beyond the boundaries of the heliosphere. Nanojets and Nanoflares. Nanojets are bright, thin tendrils of plasma that travel perpendicular to magnetic structures in the outer solar atmosphere, reaching lengths of thousands of miles. They are spawned by nanoflares, tiny explosions on the Sun caused by a process known as magnetic reconnection, which occurs in tangled magnetic field lines. These images showing nanojets nanoflares on the Sun were captured by NASA's IRIS mission on April 3, 2014. Plumes and plumelets. Plumes are streamers of solar material that stretch out from coronal holes, dark patches of open magnetic field, on the Sun. They appear bright in extreme ultraviolet views of the Sun, and are made up of many smaller streamers, called plumelets. Plumes play a role in creating the high-speed solar wind. Parker Spiral. The Sun's magnetic field envelopes all the planets of our solar system and beyond, carving out a vast space we call the heliosphere. As the Sun rotates and the magnetized solar wind blows outwards, the magnetic field forms a spiral, known as the Parker Spiral, that looks like the water coming out of a rotating sprinkler. Around the spiral, there is a surface where the Sun's magnetic field changes polarity, forming a wavy spiral like a ballerina's skirt called the heliospheric current sheet. Prominence. A prominence is a snake-like structure made of cool, dense solar material that is suspended above the Sun's surface by a strong local magnetic field. When they are viewed against the solar disk, head-on rather than off the visible edge, they are called filaments. Prominences can erupt and the magnetic structure becomes unstable, flinging the plasma outward in a blast called a coronal mass ejection. A solar prominence, upper left side of Sun's disk, about 10 o'clock, observed by Solar Dynamics Observatory on December 31, 2012. The prominence lasted on the Sun for about 3 hours before collapsing. A huge, handle-shaped prominence erupting from the Sun in 1999. Prominences are huge clouds of relatively cool dense plasma suspended in the Sun's hot, thin corona. At times, they can erupt, escaping the Sun's atmosphere. Emission in this spectral line shows the upper chromosphere at a temperature of about 60,000 degrees Kelvin. Every feature in the image traces magnetic field structure. The hottest areas appear almost white, while the darker red areas indicate cooler temperatures. Prominences can erupt and the magnetic structure becomes unstable, flinging their plasma outward in a blast called a coronal mass ejection. Solar flares are energetic bursts of light and particles triggered by the release of magnetic energy on the Sun. Flares are by far the most powerful explosions in the solar system, with energy releases comparable to billions of hydrogen bombs. The energetic particles accelerated by flares travel nearly at the speed of light, and can travel the 93 million miles between the Sun and Earth in less than 20 minutes. Some solar flares have an associated coronal mass ejection. NASA's Solar Dynamics Observatory captured this image of a solar flare, as seen in the bright flash on the right side of this image of the Sun, on January 20th. The image from SDO's Atmospheric Imaging Assembly 131 Angstrom channel, colorized in teal, shows a subset of extreme ultraviolet light that highlights the extremely hot material in flares. A zoom in on the flaring region. This image, captured by NASA's Solar Dynamics Observatory on June 20, 2013, shows the bright light of a solar flare on the left side of the Sun. Solar wind. The solar wind is a gusty stream of material that flows from the Sun in all directions, all the time, carrying the Sun's magnetic field out into space. While it is much less dense than wind on Earth, it is much faster, typically blowing at speeds of 1 to 2 million miles per hour. The solar wind is made of charged particles, electrons and ionized atoms, that interact with each other and the Sun's magnetic field. The extent of the solar wind creates the Heliosphere, the Sun's region of influence within interstellar space. Spicules. At any given moment, as many as 10 million wild jets of solar material burst up from the Sun's surface. Known as spicules, these grass-like tendrils of plasma erupt as fast as 60 miles per second and can reach lengths of 6,000 miles before collapsing. Sunquakes. Sunquakes are seismic-like activity on the Sun that ripple across the visible surface, not unlike earthquakes. They are known to accompany some solar flares, but scientists are uncertain how exactly they are triggered. Movie of a sunquake, the earthquake-like waves that ripple through our star. Left frame shows the active region in visible light, amber, and extreme ultraviolet, red, on July 30, 2011. Right frame shows the ripples on Sun's outlying surface up to 42 minutes after the onset of the flare, which is marked by the label IP for impulsive flare. Sunspots. Occasionally, dark spots freckle the face of the Sun. These are sunspots, cooler regions on the Sun's visible surface caused by a concentration of magnetic field lines. Sunspots are the visible component of active regions, areas of intense and complex magnetic fields on the Sun that are the source of solar eruptions. Lasting from days to months, sunspots typically stretch 1,000 to 100,000 miles across. The number of sunspots goes up and down as the Sun goes through its natural 11-year cycle. Scientists use sunspots to help them track this cycle. Granules. A close-up of the Sun's convective, or boiling, motion, with a small sunspot forming on the right, from Hino-D, a collaboration between NASA and the Japan Aerospace Exploration Agency, JAXA. The outer layers of the Sun are constantly boiling and roil with mechanical energy. This fluid motion generates complex magnetic fields that extend far up into the corona. Supergranules. Supergranules are networks of cells covering the Sun's visible surface that stretch some 18,000 miles across, more than large enough to frame two Earths side by side. They are caused by the convection of material in the Sun. Solar energetic particles. Solar energetic particles, or SEPs, are high-energy charged particles, mostly electrons and protons, accelerated by activity on the Sun. SEPs can be accelerated on the Sun in conjunction with solar flares, or they can be accelerated in space, for example, at the forefront of a fast-moving coronal mass ejection. Because SEPs are charged particles, their movement is guided by magnetic fields as they move away from the Sun and travel through space. SEPs can pose a radiation hazard to astronauts and electronics in space, and their effects on Earth's atmosphere can hinder high-frequency radio communications like GPS.